Here we have the indefinite integral of x squared minus x plus 9 dividing by x squared plus 9. The x squared plus 9, if we just have x squared plus 9, then this is called a quadratic factor. But if we have x squared plus 9 and then square, it's called repeating quadratic factor. And so to decompose something like this, if we have a quadratic, we have a repeating factor, then we have to decompose it like this. And a question might be, can we just write this as x squared plus 9 times x squared plus 9 and then decompose it like this? The problem with this is if we decompose it like this, then we end up with the common denominator of x squared plus 9, and it won't match this. And so that's why we have to have x squared plus 9 and then x squared plus 9 squared. And now if we form the common denominator here, then we will get x squared plus 9 squared. And so this is a quadratic factor. And so up here we need 8x plus b, and then over here we need cx plus d. And so that's how we decompose repeating quadratic factor. And then to add, and so right here we can cross multiply. And then plus the cx and then times this, and then dividing by the product of the two denominators. So this is one way of doing it. The other way is we can just multiply the top and the bottom here by x squared plus 9, and then we'll end up with the common denominator of x squared plus 9 squared. And if we do it like that, then we'll end up with this. So here we cross multiply the 8x plus b times x squared plus 9 squared, and then we cross multiply here the cx plus d times x squared plus 9, and then dividing by x squared plus 9 times x squared plus 9 squared. But then we end up with x squared plus 9 up here, and then down here also. And so if we, which means we can reduce, or we can divide everything on the top by x squared plus 9, and then divide everything on the bottom by x squared plus 9. And then we end up with this. And so for repeating, for problem with repeating quadratic factor, it's probably best to just multiply the this quotient right here, multiply this by x squared plus 9, and then multiply this by x squared plus 9, and it'll be less work. But either way, it will end up like this. And so now we have the two denominators match, and so now we have to have the two numerators match. And then multiply this out. So 8x times x squared, it'd be 8x to the third. And then 8x times 9, so it'd be 9 times 8x. And then plus bx squared. And then plus 9b and then plus cx and plus d. So this is 1, this is 1, and then since we have an x to the third over here, so on the right side, so let's go ahead and put 0 x to the third here. And so over here we get 8x to the third, and then plus bx squared. And then we have 9, 8x and plus cx. So that will be 9a and then plus c and then x. And then we have the constant, just d. D is the constant. And then the 9b is also constant. And so the coefficient of the x to the third must match on the left side, must match of the coefficient on the right side. So we have to have 0 is equal to a, and then 1 is equal to b, and then negative 1 must equal to 9a plus c. And then the 9, this must match the 9b plus d. So we end up with a is 0, b is 1, and then from here we have negative 1 is equal to 9 times 0, since 8 is 0, and then plus c. So we have c is equal to negative 1. And then from here we get 9 is equal to 9, b is 1, and then plus d. So we have 9 plus 9 is equal to d, and so d must be 0. So here we have a is 0, and then b is 1, and then c we have negative 1, and then d we have 0. So 0x plus 1, that's just going to be 1. And then this will be negative 1x. And then now we have to find these two integrals right here. Recall that we have an integral involving inverse trigonometric functions. And so we have an integral like 1 over a squared plus x squared. Then it's 1 over a times the tangent inverse of x over a. And so the integral that we have here is 1 dividing by x squared plus 9 dx. And so here a squared is 9, and then x squared is just x squared. And so we have a squared is 9, so 8 is 3, and then tangent inverse of x over 3. Once again, the a squared is 9, and so a squared is 9, and therefore 8 is 3. And so that's why we end up with 1/3 tangent inverse of x plus 3. And then the other integral, we have negative x. Let's go ahead and move the negative outside, so it makes it easier. And so the second integral is x, and then x squared plus 9, and then square. And then here we can just do a u substitution. And so du dx is equal to 2x, or du is equal to 2x times dx, and then multiply both sides by 1/2. And so now we're ready to make the substitution. So this is the same as this. This would be 1 over, now we let u be x squared plus 9, so this would be u squared. And then x dx is 1/2 du. And then we can move the 1/2 and place it in front of the integral. And then 1 over u squared, that's the same as u to the negative 2 du. The antiderivative for u to the negative 2, add 1 to the exponent, we get u to the negative 1, and then dividing by negative 1. So this becomes negative 1/2, 1, and then 2 times negative 1 is negative 2, 1 divided by negative 2 is negative 1/2. And then u to the negative 1, that's the same as 1 over u. And so we end up with negative 1 and then 2 times, but u is x squared plus 9. And so this integral is 1/3 tangent inverse of x to the third, and then this integral is negative 1 over 2x squared plus 9. And then we have a minus right here, minus right here. And that's the answer. That's the answer.